Jai Hind everyone. Today we are going to discuss a topic which is very popular in C programming language, that is functions in C. So before going into detail, let me discuss what the functions is. When we say function, what comes in our mind? This terminology says that few of the operations, few of the instructions are to be followed by someone. A function has to be performed. It has to perform such type of functionalities and such type of things and so on. Similarly, in the case of programming languages, especially we are discussing the example of C language, a function is a block of code which performs some specific task, right? So we can say it follows a modular approach. Now the question arises, what is a modular approach? Modular approach that includes that we can have multiple modules in our program, right? Those modules could easily be reusable, right? So that instead of writing a specific task again and again, we can call a particular function multiple number of times whenever we require, right? So that's how it supports or it follows the modular approach. So let me discuss what the modular programming is. We can see the use of a user-defined functions that allows a large program that has to be broken down into number of smaller self-contained components, each of which has some specific task, some identifiable purposes it is going to solve, right? So when we say self-contained components, that means it will be having some of the task that has been assigned by the developer. For example, suppose I'm creating a function to add two integers. So what this function will do, it will take the value of these two parameters which we are passing from any other function. For example, I'm calling a function sum from the main function. Right? So what will happen? These value of these parameters will be passed over here, and here I'm calling a function, and what this function is going to perform, this function will be performing a operation to addition of two integers, right? It is going to add two integers. That means whatever operation we are going to perform, the complete set of statements will be there in this function only. Fine. So next we can say each of which has some unique identifiable purpose. Suppose there are multiple functions in your program. Each of them will be performing some of a specific operation. Like one function I have prepared for adding two integers, maybe another I'm creating for difference, subtraction, right? So here we will be calculating the difference. Another function we can have, say, multiply. So that's how we can see that each of these functions are performing some of a specific task, a unique task. We can identify with this, with a operation, what operation it is going to perform. Sum, we can see that this is performing summation. Subtraction, it is performing subtraction. Multiplication, it is performing some multiplication, right? So that's how we can see whatever number of functions we are having in our program that should have self-contained components, that needs to be unique and should solve a identifiable purpose. Thus, a C program can be modularized through the intelligent use of such functions. Now we say why we require modular approach. What is the requirement of modular approach in our programming language? So we see many programs require a particular group of instructions to be accessed repeatedly from several different places within a program, right? When we say repeatedly from the several different places within a program, that means we have created one function and whenever we require, we can simply call that function, right? For example, I've created a program where I've created a function to calculate the discount, right? So, at the time of billing, whatever type of discount we are going to give to the user, to the customer, we need to simply select what percentage of discount you are going to provide. Say X category 5%, Y category 10%, Z category say 15% or 20%. That means multiple number of times again and again I am calling that function discount, right? It is not mandatory that whatever function I am using within my program, it has been mentioned in that program only. We can create our functions anywhere, wherever we want. Suppose, for example, I have created one of my header file, and in that header file, I have created multiple functions, right? So now, whenever I'll be in need to call those functions, what I need to do is I'll simply be including that header file into my program, and then I can use those functions. Pre-compiled functions which I've already created in another file. What I need to do, I simply need to import that header file into my program, right? So we say the repeated instructions can be placed within a single function, which can then be accessed whenever it is necessary, whenever it is required, right? Moreover, a different set of data can be transferred to the function each time it is accessed. Like I've given you an example. Okay, suppose for the X category, a user is buying a X category, and for that you are providing 5% discount. The next user is having some of the products of Y category, and for that you are providing 20% discount, right? So every time the value of the discount that is getting changed, right? It could happen. So we say a different set of data can be transferred to the functions. Thus, the use of functions avoid the need for redundant, or we can say repeating programming of the same sort of instructions, right? So that's why it is quite popular. The modular approach is quite popular. So now we can say a function is a self-contained program segment that carries out some specific well-defined task. Likewise, I've explained up till now. Every C program specifically consists of one or more function. But what is the condition? If there is just a single function in your program, it has to be main, right? Why it is so? Because main is the entry gate of any of the C program. Compiler will start reading from the main function only. So that's why it is mandatory, if there is just a single function in your program, that has to be main. While we are defining the functions, there is no any specific order that the function 1 or function 2 or function 3, no any sequences is specified. Likewise, in the last example, I have created 3 functions. One was sum, second was subtraction, third was multiply. Right? We can create functions, we can define our functions in any of the order. Right? What matters? The calling of function matters. The function will be performing its task according to the call of that particular function. Suppose we are calling sum from the main. So, the control, whenever we are calling a function, control will be transferred immediately to its definition. Right? Okay. Then all of these statements will get executed. Once the task has been completed by this function, control will be returned to the calling function only. Control from the called function will be returned to the calling function back. Right? Now suppose after this I am calling another function, say multiply. According to this, multiply is my last function, right? Wherever I have defined the function, that doesn't matter. Once this call has been made, control will be transferred to that definition. All of its operations, all the instructions will be performed, and then control will be back to the calling function only. Right? So, we say the definition of the functions may appear in any of the order in a program file because they are independent of one another. Right? Function can be executed from anywhere within a program. You can call a function within another function as well. Right? Once the function has been executed, control will be returned to the point from which the function was exist. That means control will be returned to the calling function only. Right? Functions contains special identifiers which are called parameters, or also we used to say arguments through which information is passed to the function, and from functions information is returned via the return statement. Right? We are passing, how we are passing the values, how we are passing the parameters. With the help of the parameters, we are passing the value. Right? The operations will be performed and it will return some value with using return statement. It is not necessary that every function must return some information. But up till now we have studied that every function has to return some value. Then it becomes a contradiction. Now we say, I repeat, it is not necessary that every function must return some information. There are some functions which also do not return any information. For example, the system defined function printf. The system defined function printf. What printf is doing? Printf is a output function. What printf is? Printf is an output function. Why it is output function? Because with the help of a printf statement, we used to display some value, right? So now we'll move further towards the function definition. What is the function definition format? In the last slide, we have seen that it returns some value. How it is returning some value? What does it mean by the return statement? I'm going to discuss in the upcoming slides. But we have to include the return value type. What type of value this function is going to return? Number one, right? Then function name. Function name, what is the function name? Any valid identifier we can use over here, right? Function name is a user defined a valid identifier name. Then we will be having some parameter list. After that, some of the declarations and the statements will take part, right? So function name, any valid identifier name we can take. Return value type, that is data type of the result. That means what type of value it is going to return. If we have mentioned void, say void display, this function I have created. That means it is not going to return any kind of value. Fine. On the other hand, what type of value it is going to return? It is returning C. And what type of C is? C is of type integer. C is a variable that is of type integer. That means it is going to return integer type of value. This function, we have included void that says it is not going to return anything, right? So void indicates the function returns nothing. What is parameter list? A comma separated list declares parameter, like over here I have declared A comma B. These are the parameters. These are the comma separated list. A type must be listed explicitly for each parameter unless the parameter is of type integer. Unless the parameter is of type integer. Why it is so? Because int is the default type, right? If we have not included the type of the function, that means it is going to return integer type of value because it is default, right? Otherwise, we have to specify either it is going to return float type of value, it is going to return character type of value, and so on. So, next we will discuss the declaration and the statements. We will be having a function body which is known as a block. That's what we are saying, a block of self-contained statements, right? So, here variables can be declared inside the blocks, can be nested, fine. Function cannot be defined inside other function. This is very important point to remember. We can call n number of functions from the other functions, but functions cannot be defined inside the other functions, right? Returning control, if nothing is returned, okay, return simply or until reaches the right braces. If something is returned, likewise we have seen in the last slide, we were returning C, then C has to be included, right? That expression has to be included, fine. So, now we will see a function prototype, why it is required. As I told you, the default type is integer. So if we are not including anything, the type of a function, what type of value it is going to return, in that case, it will return integer type of value. The compiler will expect that this function is going to return integer type of value, right? Otherwise, we have to specify, fine. So the function name, comma, parameters, what the function takes in, what type of value it is going to return, that means the data type of that function, right? Default is integer. Prototype declaration is not essential, it is optional. When it is optional, if a function has not been declared before it is used, compiler will assume that the return type is an integer and that the type of parameters match the formal definitions. If these assumptions are wrong, the linker will not be able to link. That will fail, right? I'll take the example of prototype. Say int maximum. Maximum is what? That is a function name. We are trying to calculate the max out of 3 integers. The maximum value out of 3 integers. So function prototype, we will be declaring like the type, return type of a function, then function name, as I told you, any valid identifier name, a user defined identifier name, say maximum. Then out of how many numbers I'm going to calculate, I'm going to find out maximum out of 3, then I have included 1, 2, 3 integers over here. What it is going to take? It is going to take 3 integer type of values. And only one number will be maximum out of 3. So it is going to return an 1 integer value, right? So here I'm going to discuss one of the example where what we are trying to calculate, we are trying to find out maximum out of 3 numbers, fine. So what we are doing, we are calling a function maximum and we have passed the parameters. What is the value of A, B and C? We have taken an input from the user, right? Suppose user has given 10, 20 and 30. 10, 20 and 30, right? So the value of A will be 10, the value of B will be 20 and the value of C will be 30, right? When we are calling a function, control will immediately be transferred to its definition, right? Here we will see how these values are getting copied. When we are talking about the call by value, in that case, these are what? These are the actual parameters. Here, these parameters are known as formal parameters. The value of actual parameters will be copied into the formal parameters. I repeat, the value of actual parameters will be copied into the formal parameters. That means what matters? What is important in this case? Number 1, how many types of, how many formal parameters, actual parameters are there? How many parameters? 1, 2, 3. 3 parameters are there of type integer. Then first and foremost thing, we need to take care that all of these, the formal parameters, are also required to be of type integer, right? Okay. Type, number and order. Type of parameters, actual parameter and formal parameters, that must be same. Then number of formal and actual parameter that has to be same. Find plus order of formal and actual parameters that has to be same. That means the value of A will be copied to X, the value of B will be copied to Y, the value of C will be copied to Z, right? The type, number of formal and actual parameters, and the order of formal and actual parameters, that is what matters, right? So in whatsoever order you're calling, accordingly that will be copied over here. Fine. Now we have 10, 20, 30. The value of X will be 10. The value of Y 20. The value of Z, that is 30. That has been copied, right? Now we have taken another variable and have I've assigned the value of X to the max. I have taken another variable max and I have assigned the value of X to the max. That means initially what I did, I have taken max is equal to 10. Now what it is going to do, I have included a condition if Y, what is the value of Y? That is 20, greater than max. If it is greater than max, okay, that means X is not max, right? In that case, the value of max has to be changed. So we have assigned max is equal to the value of Y, which is 20, right? This is when this condition is true. Suppose this condition is not true, then it will check if Z is greater than max, right? Then it will check either the value of max is smaller than Z. Okay, the value of Z is 30. 30 greater than max. Condition is true because the value of maximum is 20, right? So max equals to Z. Fine. So that's how it will be checked and calculate, and then whatever the final value of max is, it is going to return that value to the calling function. Fine. So that's how it will return the value of the max, and then that will get displayed over here, right? Another example I have included to explain the concept of prototype of a function. Here in the first example, I have not included any prototype. Fine. So we will be having a error, right? For now, what we have done, we are calling a function square, and in that square, what we are trying to do, we are trying to find out the square of a number, right? So we have passed a number as an actual parameter. Okay, what type of value it is going to return? It is going to return float type of value. Fine. But we have not included a function prototype over here. The default compiler takes that is of type integer, right? So except integer, in many of the cases, in rest of the cases, we have to include the function prototype, right? And that's how we include return type, function name, and parameter list. As simple as that. Fine. Now we can call this function. It will be called and it will return the value of square. Fine. So two type of functions, function calling is there. One is call by value, another is call by reference, right? In call by value, we have seen we pass the value of the parameters, right? Like in the last program, we have seen we are passing this value, right? When this function has been called, this value is getting copied into the formal argument or the formal parameter, right? But when we say call by reference, there instead of value we will be passing the address of a variable, right? So for now we will be focusing on call by value only, as we have discussed lot many programs. Fine. So these are some of the points, like copy of the arguments passed to the function, changes in the function do not affect the original. Fine. Why it is so? Because copy of a argument is getting passed. We are not working on the actual value. Fine. So that's why it does not affect the original. Use when function does not need to modify the argument, right? There may be some of the accidental changes. So call by value avoids those accidental changes, right? So for now, I'll rest my lecture here only. In the next video, we will be discussing about the call by reference. Here, these are some of the references from where I've included the content in my slides. Thank you.